Hey guys, today we're going to have a look at quadratic equations. Up until now, we've really just been looking at quadratic expressions, ax squared plus bx plus c. But an equation is when we set that quadratic expression equal to something so that we can then rearrange it and work out what the value of x is. Now, why have we been spending so long on factorizing quadratics? Because when you've got a quadratic equation, factorizing is one of the only ways you can really rearrange it to find out the value of the variable x. Let me show you what I mean. Now, this equation here is not a quadratic. It doesn't have an x squared term. So it's a linear equation. And these equations are easy to solve just by rearranging to get the x on its own. First I minus the 4, then I divide by 2, and I've got my x by itself. X must be equal to 1.5. Simple. Let's try another one. Now this equation looks a bit harder, but it doesn't have any x squares in it. It is not a quadratic, so I can just rearrange to solve. First I'll move the 4 across, then I'll get my x's together, so I'll move the 5x across. That will simplify to be negative x, because 4 minus 5 is negative 1. So I want positive x. If negative x is equal to negative 3, positive x will be equal to positive 3. So again, I didn't need to factorize because it wasn't a quadratic. I just needed to get the x's together and then get the x on its own. Let's have a look at one more example. Okay, it may look complicated, but it is still not a quadratic. There are no x squared terms. All I need to do is get the x terms together and send all the values to the other side. I'll get the x on its own, and I'll find its value on the opposite side of the equation. So my first step, just like in the previous example, I'll move the denominator across and multiply. I'll expand that out. Then I'll get my x terms together, and it's generally easiest to move my smaller x term, so my negative 12x comes over to the other side and becomes plus 12x, and my minus 8 came over to the other side and became plus 8. So that's 13x equals 16, and x on its own would be equal to 16 over 13, which of course we could work out as a decimal. Now none of these were quadratics, so in all of these cases I could get x on its own. However, look at this example. This is a quadratic. I've got an x squared term, an x term, and that's equal to some number on the other side of the equation. Now, I can't, no matter how hard I try, get my x's together here. I can't add x squared with 2x. They are not like terms. And just moving the x squared to the other side and then dividing by the 2 might leave you with an x on its own, but you've got an x squared on the other side of the equation. So that's not going to give you the value of x. This is where we need to use the new method of factorizing. So we need to first set the quadratic equal to 0, and I'll explain to you why we're going to do that once we get to the end of this. And then we need to factorize. So here's my quadratic. I need it equal to 0, so I'll move that negative 1 over to the other side so that it's with all the other terms, and that leaves me with nothing, so 0 on the right-hand side. Now I've got a quadratic, x squared plus 2x plus 1, and it's equal to 0. So I'll go ahead and factorize that, thinking about what numbers multiply to make 1 and add to make 2. That's positive 1 and positive 1. So I've got x plus 1 and x plus 1 equals 0. Now, what was the point of all of that? We know how to factorize quadratics, but why do we do that? Well, when I have a quadratic that is factorized and set equal to 0, I know that either this is equal to 0 or this is equal to 0, because two numbers that multiply to be 0 must either be 0 times something or something times 0. In this case, both of the brackets are the same, so it must be that x plus 1 equals 0. If x plus 1 equals 0, that's a nice linear equation I can easily rearrange, get x on its own, send the 1 to the other side. X is equal to 0 minus 1, so x equals negative 1. Now, since both of those brackets are the same, I've already got my answer. X must be equal to negative 1, because then negative 1 plus 1 would be 0, times negative 1 plus 1 would be 0. 0 times 0 does make the answer 0. I can also check with the original quadratic, substituting negative 1 into x squared plus 2x minus 1. So the x squared becomes negative 1 squared, and negative 1 times negative 1 is 1. Plus 2 times negative 1, that's going to be negative 2. So that's 1 minus 2, and that is negative 1. So I've got my answer. My answer was this answer here. x must be equal to -1. That's the value of x that would make this equal to -1. Let's see another example, because as you know, quadratics may have one answer, like this one, or two answers, or no answers at all. So here we've got another quadratic equation, and this one's even more complicated, because I've got x squared plus 2x on one side, and it's not equal to 0. There's a whole other expression on the other side. First, I need to set the quadratic equal to 0, and then factorize. So since I've got my x squared on the left-hand side, then I'm going to pull everything over to the left-hand side and leave 0 on the right-hand side. So I'm going to do x squared plus 2x minus 2x minus the 4. Whatever was positive on this side becomes negative on that side. Right? So that can simplify. X squared plus, that will cancel out. Plus 2x minus 2x is 0x minus 4. So that's going to be x squared minus 4 equals 0. Now I've got a quadratic, and it's equal to 0. It may not look like a quadratic because it only has two terms, but it does have the x squared term, so it is a quadratic. It's a special kind of quadratic, two terms with a minus in between. Both of those terms are squared terms. X squared is a squared term, and 4 is the same thing as 2 squared, so it's a squared term. Difference of 2 squared, dots. So setting up my bracket should be easy then. I know I'll have x in both brackets, and I know that the number in both brackets will have to be positive and negative of the same value. Positive and -2. They multiply to make -4 and would add to make 0, which is why there's no middle term. So I've got my quadratic, it's set equal to 0, I factorized it. Now that means that either this bracket is equal to 0 or this bracket is equal to 0. Because if two things multiply to make 0, at least one of those things needs to be equal to 0. So if x plus 2 is equal to 0, that means that x must be equal to -2. That's one of my answers. It might be that x is not equal to -2. However, the second bracket would then need to be equal to 0. So if x minus 2 is equal to 0, rearranging that, x would have to be equal to 2. So that's my second answer. And again, you can check those answers by substituting those values back into the original equation. So if I put -2 in here, so -2 squared would be +4, plus 2 times -2 is -4, so that's 0. And then I put -2 in here, 2 times -2 is -4, plus 4 would be 0. That would be 0 equals 0, so that works. If I substituted 2 into this equation, that would be 2 squared, which is 4, plus 2 times 2 is 4, so that's 8. And putting a 2 in here, that would be 2 times 2, which is 4, plus 4, that's also 8. So both of these values are possible answers for what x is to make this quadratic equation equal. One more example now, and an even harder one. It is definitely a quadratic equation. I've got an x squared term, I've got x terms, I've got numbers terms, but what's going to make this difficult is the fact that there's a number in front of my x squared term. So we'll start the same way. We need this quadratic to be equal to 0. So since I've got my x squared term on the left-hand side, I don't want that to be made negative, so I won't move it over to the right-hand side. Let's move everything over to the left-hand side. So I'm going to end up with 3x squared minus x minus the 12x minus the 10. Remember, if it was positive on this side, it's negative on that side. If it were negative on this side, it would be positive on that side. Okay, simplifying this, I've got 3x squared minus, that would be 13x minus 10. Now, the quadratic, again, is a difficult one because there's a number in front of the x squared term. I can't divide everything through by that value. I can't divide everything by 3, so I'm going to need to split the middle term. Remember how we do that. I look at the first term, I look at the last term, I multiply them together, so that's going to be -30, and I think what numbers multiply to make -30, but add to make -13. And I know what you're thinking 3 and 10. But to multiply to make -30, one of those values has to be negative. So if I do -3 plus 10, it's going to be 7. If I do -10 plus 3, it's going to be -7. So let's look for another pair. What other numbers multiply to make -30? Big hint, the bigger number should be the -1. And those numbers are negative 15 and positive 2, right? Those add to make negative 13. That's why I've split the middle term into those values, and they multiply to make negative 30. Now I can factorize by grouping. Looking at the first two terms, I see that they both have x in them, and looking at the numbers, they also both divide by 3. So I can factor out 3x. And the last two terms, they both divide by 2. So I'll go ahead and factorize by grouping. I factored the 3x out of these two terms. See, 3x times x makes 3x squared. 3x times negative 5 makes negative 15x. 2 times x makes the 2x, and 2 times the negative 5 makes the minus 10. But the most important thing is that I see that my brackets do match, so I can regroup them. I'm doing 3x times this bracket, plus I'm doing 2 times this bracket. Let's put that together. 3x times the bracket plus 2 times the bracket. Right, I've factorized my quadratic. It's equal to 0. Why did I do that? I do that because that means either this bracket is equal to 0 or this bracket's equal to 0. So let's first solve this one. Rearranging this equation, it's just a linear equation, so I just need x on its own. Move the 2 across and minus it. And then move the 3 across and divide. So x is equal to negative 2/3. Or don't forget there is another possibility. I've only solved where the first bracket equals 0. It might be that this is not equal to 0. However, this one would have to be equal to 0. So the other possibility is that x minus 5 is equal to 0. If x minus 5 is 0, x must be equal to 5. That's my second answer. Now again, you can check your answers by substituting into the original equation, or you can check your answers by substituting into the factorized equations. That should be pretty clear. If x is 5, this is definitely going to be 0, 5 minus 5. If x is negative 2 over 3, negative 2 over 3 times 3 is going to be negative 2 plus 2, that's 0. But make sure you haven't made a mistake in your factorizing. So that's why it's always best to go back to your original equation, even though it might be more difficult to substitute in. Okay, let's do some practice now. So you've got 12 questions here. The first row should be the easier row, as you can see why. I've got a quadratic equal to 0 in each of these cases. The next row is a little bit more difficult. Don't forget you first need it to be equal to 0, so we're going to need to move this over to the left-hand side before we start factorizing. And then we get into two-term quadratics and some really quite interesting looking ones. These don't look like quadratics at the moment, but when you multiply that through, you will have that x squared term. Okay, so go ahead and hit pause now and give this a go.